Happy week 3. So still quarantined at home. Lady is not thrilled with me that I interrupted her nap for this video, but she'll get over it. So hopefully you're spending this quarantine time having some fun with your family, doing a little bit of math homework, and learning some new skills. So I actually have gotten a lot better at cooking. So no big deal. Made some banana bread this morning from scratch. So I want to hear some of your guys' skills that you are developing over this quarantine. But mostly just hope that you guys are staying safe and healthy. And I really hope that we are able to go back to school at some point because I really miss your faces. And yeah, I just hope you guys are doing well and you have a great week this week. Thank you guys for turning in your work. If you haven't turned in something, you can still turn it in. Just get it to me as soon as you can. Again, make sure you're showing that work and you are either sending it by email or attaching it on Google Classroom. Either way works, whatever's easiest for you. But yeah, just have a good week and reach out if you need help. Say bye, lady. She doesn't care about my video, apparently. Last week we talked about the log rules, which are still going to apply today, but now we are actually using those log rules to solve logarithmic equations. So the first thing I wrote here is just a standard form of an exponential function and then the standard form of a log function. This is a b, it looks like a 13. There we go. Now, when you have a base and then the base of the log, when those two things are the same, they end up canceling out and you're just left with a. Same thing over here. When the base of your exponential is the same thing as the base of the log and the base cancel. So over here you would just be left with x. So that's kind of the principles that we're applying today. And I rewrote these log rules just to help us out. So the first part of your assignment actually doesn't really require these log rules yet. So I think it's 1 through 6. You're just literally making something into an exponent. So instead of trying to rewrite this, all I want to do is change it so that the log is now the exponent. So in order for the log to cancel, the important part is this 18. So 18 is going to be the base, and now this log 18 of negative 4m, now that is the exponent. And I'm going to do the same thing on the other side of the equal sign. So 18 is the base again, and now this becomes my exponent. Log 18 of 8 minus 3m. Okay, so again, just like I was talking about earlier, when the base and the log base are the same, that log and that base cancel out. So all I have left here is negative 4m. This marker is about to die. And then again, these two cancel as well. So over here, I'm just left with the parentheses, 8 minus 3m. So now this is just a hopefully nice, easy two-step equation. So plus 3m plus 3m. So negative 1m equals 8. And then dividing it by negative 1, m would equal negative 8. So there is your log equation. So let's do another one. So that was number 1 on your first assignment. So let's go ahead and do number 2. So log base 16 of 4 minus 2r equals log base 16 of r plus 7. So this is number 2 on your assignment. So again, we're doing the same principle. We're making the log into the exponent, but we're doing that by that particular base. So in this case, it's going to be 16 instead of 18. So 16 is now the base of that exponent, and the log base 16 of 4 minus 2r, that becomes the exponent. So that's why I write it really small, because it's the exponent now. Okay, same thing over here. 16 is the base. The new exponent is log 16 of r plus 7. So once again, just like before, the 16 and the log base 16 cancel. So I'm left with 4 minus 2r on this side. And the 16 and the log base 16 cancel on this side, so I'm left with r plus 7. So solving, I'm going to subtract r, and that will give me 4 minus 3r, oh man, equals 7. All right, that guy is dead. All right, and then I subtract 4, so negative 3r equals 3. And then again, dividing by negative 3, r would equal negative 1. So there is number 2. All right, so those are hopefully fairly simple, just making that base of the log the base of the exponent so they cancel. So let's do some where we have to use those log properties that you guys worked on this past week. So for example, number 7 on this worksheet is log base 4 of x plus 6 plus log base 4 of x, and that equals 2. So as you can see, there are 2 logs on this one side of the equal sign instead of just 1. That's a problem. This is where those log properties come in. So that's why I had you guys practice those. So if I was going to rewrite this, addition, when it comes to logs, means what? Hopefully you said multiplication. So I want to make this into one single log. So I have x plus 6, those get multiplied, and that equals 2. That is my new problem. Okay, so now this can become what it was originally. So in order to get rid of this log, I have to make it the base, which is 4, and then I make the log the exponent. Now, on the other side, I still have to make this the base. So 4 is still the base. But the other side doesn't have a log, it just has a 2, which means that is the only thing that is my exponent. So everything in pink became an exponent, as you can see. So those end up canceling out, and I'm left with x plus 6 equals, now 4 squared I can change to 16. Okay, so now I'm going to distribute this. X times x is x squared plus 6x equals 16. Okay, so basically I just distributed this. Hopefully that made sense. Now, when I have x squared, I want this side to equal 0. So I'm going to subtract this 16. So that way I have x squared plus 6x minus 16 equals 0. okay? And since this is that factoring stuff, which I know we loved, I need a number that multiplies to negative 16, but when I add them together, I get 6. So two numbers, multiplying to negative 16, adding to 6. Hopefully you said positive 8 and negative 2. Okay, so when I get my answers, remember we just switched those signs. So x plus 8, this would just give me negative 8, and this would give me positive 2. Now, if I go back up here and check this, negative 8 plus 6 would give me negative 2. So let me just show you something in the calculator. So if you are wanting to check this, okay, press math, and then you should see log base after you press math. That allows you to put in that base number. You can't just press log in your calculator. So that means my laundry is done. Sorry about that. So log base 4 of, we had negative 8 plus 6. Now, do you see how it says non-real answer? That's a problem. You cannot take the logs of negative numbers. But if I go back here and I do that, do this math thing one more time, go down to log base again, and I do my other answer, 2 plus 6, you see I actually get an answer. So the first one, when I put in negative 8, gave me an error. The second one, when I put it in, gave me an actual answer. So if you get an error, that means that you have what we call extra solutions or extraneous solutions. So this actually cannot be an answer. This is the only answer you should get. Now, you're only gonna have to worry about this if you have x squared. So if you end up having to factor it, that's when you need to go back and look and see if you have an extra answer. Okay, so your answer can be negative, as you saw on the front. We had negative 1 be an answer. But it's just when you plug it back in, that's when it becomes a problem. So you should only have to check it if you end up with x squared, which I think you only have a few of those. So only check when there is x squared. All right, so let's do another one. And let's just do number 8. So log base 2 of x minus log base 2 of x minus 2 equals log base 2 of 43. All right, so we have a whole bunch of logs this time, but there's 2 on this side. Again, that's a problem. We want to condense it. What does subtraction mean? Hopefully in your little bedroom or room or dining room or wherever you are, you out loud said it means division. So that means I have x over x minus 2. Okay, because again, this divided by this. And then over here we have log base 2 of 43. Now we're going through the same process to get rid of the logs. So 2 becomes the base, log base 2 of x over x minus 2, that becomes the exponent. And then over here, 2 is again the base, log base 2 of 43 is the exponent. So we know 2 and log base 2 cancel. That's why we did that. So over here, we should just have x over x minus 2. And then on this side, what do we have? Should just have 43. Okay, so it's been a while since you guys had x on top and on bottom. Remember, these guys are married, so we can't just cancel those x's out. So I'm going to actually multiply by x minus 2. That way it gets it out of the denominator. So I have x equals, I'm going to go ahead and distribute this, 43x minus 86. Okay, so now I just get my x's together. So that would be negative 42x equals negative 86. Divide by negative 42. Okay, so if I do that in my calculator, what did I have? Negative 86 divided by negative 42. Don't like decimals. What do I like? I like fractions. So 43 over 21. Should be my simplified answer. So main thing to focus on is reducing or condensing, like you guys learned last week, the log. So it's one log equals either a number or another log, then making that log into the exponent so that the bases and the logs will cancel. And that's basically it. If you have further questions, again, feel free to email me, but just make sure that you look back over those condensing rules and your condensing assignment from last week. That will probably be really helpful. But again, I'm always here if you need help.